Let's pull a card from a deck of 52 cards and find the probability that what we pull is a 10 or a face card. Typically when we see the word or, we're adding two separate probabilities together, and while that's still the case with these examples, one thing we have to be careful of is whether or not the two things we want to have happen have any overlap in them or not. If there's any overlap, we have to be really careful because we'll be adding extra cards with the overlap. So for example, let's take a 10 or a face card. There's no overlap there. A card that I pull out cannot be both a 10 and a face card. So the probability of either of those things happening is the sum of each individual probability. To pull a 10 out, there's 4 10s in a deck out of 52. In addition to that, I want to know about getting a face card. Well, there's 12 face cards, the jacks, kings, and queens of each suit, out of 52. So the probability that one of these things happen is just the sum of the individual probabilities. That gets me 16 out of 52, or if I change that into a fraction, I've got 4 out of 13. Again, I can express that as a fraction, a decimal, or a percentage if I want to. This is something that we'd call a disjoint probability, or a disjoint event. There's no overlap. Compare that to our next example if we go down below though, however. This time they ask for or, which typically means we're going to add things together, but this time notice the difference. They want a face card or a spade. So at first glance it may not seem any different. There's 12 face cards in a deck out of 52. In addition to that, spades, there's 13 of those out of 52. However, if we think about it, this is not the same situation. This situation is no longer disjoint because there are some face cards that can also be spades. For example, the king of spades and the queen of spades. So I have some overlap with this one. What I need to do anytime I have a probability where there's an overlapping going on, I need to subtract off everything that overlaps. So I have to think of all the cards that are both face cards and spades. There's 3 of those: the king of spades, the queen of spades, and the jack of spades. So I need to subtract off those pieces that overlap. In this case, once I do all this, I end up with a probability, once I simplify, of 11 out of 26. And again, I can go ahead and change that to a fraction, decimal, or percentage if I want to. But there's your key, making sure you check for overlap. Our next 2 examples have us dealing with the probability that we pull out a card that meets 2 criteria. They have the and in there. We don't have to worry about overlap with the and problems, but they can still be a little bit tricky. So again, I'm pulling one card out of the deck and I want to figure out what's the probability that it's both a face card and a 6. Well, if you think about it, since face cards are kings, queens, and jacks, and 6s are 6s, there's not one single card that can be both of these. So my probability of this event actually is 0 out of 52, or just 0% chance. I can't get a card that's a face card and a 6. No such card exists. Next up we have an and. This time they ask us whether the card's going to be a king and a heart. Well, again, I'm only being dealt one card, or pulling one card out, so that's the key of this. Well, thinking about any cards that meet both of these criteria, well, there's only one of them. It's the king of hearts. So my probability that my card is a king and a heart is just 1 out of 52, because there's only one card that meets that criteria. Okay? Moving back to the ors, once again, the or problems are going to involve us adding individual pieces together, but we have to make sure we think about, is there any overlap going on or not. So let's start with the probability of drawing a king. There are 4 kings in a deck out of 52. In addition to that, I also want to get, or I want to get a heart. There are 13 hearts in a deck out of 52, but before I just add those together and finish, I have to think if there's any overlap. Are there any cards that are both kings and hearts? And yes, there's one, the king of hearts, that actually we pulled out up here. So I want to subtract off that overlap. There's one card that overlaps and meets both parts of this criteria. Once I simplify that, I end up with a probability of 4 out of 13. Last up, we have this idea of what's the probability that we pull a card that's not a certain card, so not a club. One way to do this, and I kind of have a little blurb about it down here, one way to do this is to actually find the probability that you don't want. So in fact, in this case, let's figure out the probability that we actually do get a club. The probability that I get a club is 13 out of 52. However, since I don't want to end up with that, I can subtract this from 100%, or just 1 in this case, to figure out the probability that I am looking for. it's not the only way to do it. In fact, I'm going to end up with 39 out of 52 once I do that subtraction, which, if I think about it, this not a club thing, there's 39 cards that are not clubs in a deck. So there's two ways that we could think about doing that. Either this is called finding the complement, when I find the probability of what I don't want. Simplifying this gets me a probability of 3/4.